Hey everyone, welcome to my video on using disks and washers with non-axis rotations. And what I mean by that is rotations around either horizontal or vertical lines that are not the X or Y axis. So we're not going to do any slanted lines or curves or anything like that, but just rotations around horizontal lines, vertical lines, but those that are not the X or Y axis. So if you want to, say, look at the solids, I have the link for Calcplot 3D right there. So if you want to look at those, you can. But we're going to go ahead and just start with this first question right here. So find the volume of the region bounded by these two curves. F is the square root of 6x minus x squared. G of x is the sine of pi over 3 times x. And we're going to rotate, instead of the X or Y axis, around this horizontal line, Y equals 3. So that's this dotted line that's right there. Now, the main thing that you want to do on these is to make sure you get your R's correct. So if we're going to do washers, we're looking at radii as coming out from this axis. So we're going to draw in a few labels here in just a second. And then those will be useful when we're figuring out what is big R, what is little r, that sort of stuff. So label the arrows above. If you think about it, anything coming from here up is going to be a y value. So I could say this is like a y1 and a y2. We're given these functions f and g, so I might go ahead and use those labels. So this sine function right here is right there on the bottom. So I'm going to say from my x-axis up to there, that would be a distance, we'll say g of x. And I may not keep the of x notation on all these, but g of x, f of x, that sort of thing is what you're looking at. If I go all the way up to here, this would be my function f. So from the axis all the way up to that point that I'm looking at right there, I'm going to think of that as a distance f of x. And then from my axis all the way up to this rotation line, how far is that? So that, for this particular one, we can see is right there at 3. I'm going to label that 3. Now, the question that we're going to need pretty soon is how far is the remainder of this distance. So if I go all the way up to 3, but I don't need all of this part here, that's my f of x, then what's left over is just going to be 3 minus my function f, or f of x. If you want to put it in that way, you can. This part right here, again, the same, total distance 3 all the way up minus whatever this g of x portion is. So this would be 3 minus that g of x. And those, like I said, will be useful for part B. So part B, draw the washer that's formed, and then we're going to set up an integral. So I'm going to go ahead and draw the washer, and we'll label our r's. So this is going to be something like this, rotate it around, and then something along these lines. That gets rotated around for that guy. So there's our washer. Coming down this way, this is going to be our little r to that inside piece, and then all the way down here, this is going to be my big R. So all the way, or if you're going all the way to the rectangle right there. So this is big R, this is little r. And notice those are going to correspond with these pieces right here. So this 3 minus f of x, that's going to be our little r. This 3 minus g of x all the way down to here, that's going to be our big R. And you'll often get these sorts of things. For these, sometimes if maybe one of your curves is a constant, you might end up with a number, but a lot of times you'll get this 3 minus one function, 3 minus another function, or whatever line you happen to be using. That sort of stuff for this big R and little r. So those we can use, remember, in our washer formula, which is the pi big R squared minus pi little r squared. In this case, we're using a small left to right movement, so that width is dx. And we'll go ahead and plug in those big R's and little r's right there when we set up our integral. All right, so let's go ahead and write out what we're going to do. So this is going to be integral of pi times big R squared. So we'll get pi, and then the big R, I'm just going to write in 3 minus my f, or actually big R was g, so let me erase that real quick. So I have that big R getting replaced with 3 minus g, and I'll go and replace my little r with this 3 minus f definition that's right there. So there we get 3 minus f of x, and then we're going to square that. So remember, that whole big R gets squared, the whole little r gets squared, and then we have that dx. All right. And we'll go ahead and put in bounds. So x's are going to run here at 0 all the way over, and you can think of your usual rectangles running all the way across till we get to 6. So I'm going to end right here at 6. So we'll say 0 to 6. All right, and then pick your favorite way to calculate that out. So if you need to actually replace the f and g with the function above, you can. Usually I'll just write those into Desmos. I'll go ahead and do that real quick. All right, so I've gone ahead and put in that f function, which is that square root function, the g, which is the sine, and then if you want to shade it, you can do something like this, g less than or equal to y less than or equal to f of x. Get the less than or equal, you can just type in less and then the equal sign and it'll change it. So that's only if you want to shade it in, you don't have to. And then here's my integral, 0 to 6 pi times that 3 minus g of x squared minus pi times that 3 of f of x, again quantity squared, and then my dx. So we get about 162.81. And if you don't like all the parentheses, you can also do like, y1 instead. And, I just have to use y1 instead of my f of x that you type in. So sometimes that can be easier to type in just y1, y2 instead of f and g on some of those. But 162.81 is what we'll get right there. So we'll go ahead and write that down, and that'll be my final answer, and that'll be cubic units of whatever these happen to be, inches, meters, feet, whatever it happens to be, cubic, whatever units you got. All right, let's go and try one more here, and then we'll call it good. So let's do part B with the x equals 2 on this one. So let R be this region bounded by f is square root of 2x, g is 1/8 x to the 4th. Find the volume rotated around these axes. And we're doing x is 2, so that would be vertical axis right here. And if we're doing that, then we want to make sure we're using, for washers, these horizontal rectangles right here. Again, a little bit later on, there's another method that uses vertical, but for washers, you're going to need these perpendicular pieces that are right here. So like something along those lines. And again, we're just going to look at what is my big R, what is my little r. So big R is going to be from my curve out to here. So we would say this distance right here would be my big R. And looking at this function, this would be my square root of 2x function that's heading out this way. Should keep going, kind of flattening out. But this would be my f right here, square root of 2x. The problem is I'm going to want this in terms of y, right? This is a little dy. So I'm going to go ahead, just so I don't have to keep scrolling up and down, I'm going to say this is x equals 2 right here for part B, and we'll just go with that. So let's figure out my big R. So big R is going to be this value of 2 all the way across minus this little bit right here that's f of x. So this is going to be 2 minus, right now it's just whatever that happens to be. I'm going to call it x1. So remember f is this vertical distance, so I should probably label that as x1. To get that, we're going to need to rearrange this, right? So let's go and rearrange this. So I'm going to say right here we got y is the square root of 2x, and we'll go and square both sides. So we got y squared is 2x, and then divide by 2. So 1/2 y squared is going to be my, what I'm going to call x1. So this will be 2 minus that 1/2 y squared. So I have to do some rearranging on this. Again, there's not really a nicer way to do that unless you use a different method. So little r, that's going to be just from here to here. So this distance right in here, that's going to be what we call little r. And this whole length here is my x2. Right? So I'm going over to this x2 value, and then I want to subtract that from 2. So this will be 2 minus x2. And if I go ahead and try to solve this g of x for x, we can see what that might be. So again, here I get something like y is 1/8 x to the 4th. It's multiplied by 8, so we got 8y is x to the 4th. And then I can just do a 4th root. So 4th root of that 8y. And you could think about simplifying roots and all that kind of stuff. Not really going to help here, but really you just need that function. We're going to approximate it anyway. So this is going to be 2 minus that 4th root. So 2 minus that 4th root of 8y. And when you're typing that in, you may need a 1/4 power. So you could also do 2 minus 8y to the 1/4. If you're not sure how to type in roots of it, other orders, you can always just change that to fractional power. So that's what I'd use for my little r. So go ahead and try to set up the integral. Pause the video, see if you can get it. I'll go ahead and write it down for you to look at when you unpause. Alright, so hopefully you got 11.73. If you want to take a look at the integral, it should look something like this. Integral 0 to 2 pi times that 2 minus this 1/2 y squared. That's going to be the first, the big R, and then 2 minus that 8y to the 1/4. That's going to be the little r, both of those squared, and with the dy. So it should be about 11.73 if you round that off. Alright. I think that will about do it. So if you want to try some of these other ones, ask questions about them in the forums, you can. But we'll go and call this video good.